The significant amounts of ammonia and water ice in Ceres indicate that this dwarf planet may have been formed beyond Neptune and migrated towards the asteroid belt when the planets in our solar system were still adjusting to their present orbits. Smaller asteroids, however, have an attraction of massive Jupiter. Sometimes, when they approach the giant planet closer than is safe, they are ejected out of the belt line in all directions. Some asteroids, however, follow orbits that bring them dangerously close to our planet. What can we possibly do to avoid an asteroid that is on a collision course with Earth? If we were to discover such an asteroid at the last possible minute, the answer, unfortunately, is not much. The first thing to do would be to study such asteroids up close. Right now, there are several ideas on how we could deflect them from their collision course. If we have many years' warning, we can target a potentially dangerous asteroid with an impactor. This will change the asteroid's speed and orbital path so that it will miss Earth. Alternatively, we could simply use a gravity tractor. In other words, placing a spacecraft near an asteroid, its gravitational pull, no matter how small, will eventually be enough to slowly pull it out of Earth's path. If, however, our time limits are exceedingly short, our only plan of action would be to destroy it. Unfortunately, there is no guarantee that its fragments will divert from its original impact path. Comets are also part of the ancient rubble left over from the formation of our solar system. Unlike asteroids, however, comets formed further away from the sun, meaning they contain large quantities of frozen ices such as water, methane, and ammonia. For thousands of years, we thought of comets as harbingers of war and other misfortunes. Eventually, however, superstitious beliefs gave way to the scientific investigation of the natural phenomena. The first important step to decipher the nature of comets was taken by the great Danish astronomer Tycho Brahe in the 16th century. Using data from two distant observatories, Brahe proved that the bright comet seen in 1577 was in fact much further away than the moon. Thus, the Aristotelian view prevailing for almost 2,000 years collapsed. If, therefore, comets are truly space objects, where do they come from? Beyond Neptune, the last of the giant planets, extends the Kuiper Belt, populated with millions of icy objects left over from the early stages of the formation of the solar system. Occasionally, some of these are deflected towards the inner part of the solar system and become small period comets. Large period comets, on the other hand, are thought to originate from the Oort cloud, an immense spherical cloud of icy objects at a distance at least 1,000 times greater than that of its coma. In other words, hair. The comet's tail, on the other hand, consists of particles from the coma dragged away by the solar radiation and solar wind. Some comets are so bright that they can even be seen from city centers despite the light pollution. Each time they approach the sun, comets lose material until some vaporize, disappearing forever. Others, however, survive their close encounter with our star and continue their space voyage back towards the far reaches of the solar system where they came from. Scientists have designed several space missions for the exploration of comets and asteroids. In 1996, for example, Giotto was the first spacecraft to provide detailed images of Comet Halley's nucleus. In 2006, Stardust captured dust samples from Comet Wild 2 and returned them to Earth for analysis. The spacecraft Deep Impact smashed a probe into Comet Tempel 1 and analyzed the material that blasted out. And Hayabusa, despite the many problems plaguing its mission, managed to return some samples of the Itokawa asteroid back to Earth in 2010. OSIRIS-REx was launched in September 2016 towards the asteroid Bennu for a surface sample return mission by 2023. However, the distinction between asteroids and comets is not always clear. Take Chiron, for example, an object that looks exactly like an asteroid. Closer to the Sun, however, Chiron spews dust and water jets, just like a comet. Recognizing their dual nature, astronomers call these objects centaurs. Asteroids and comets hide several secrets regarding the formation of our solar system, because the primary ingredients from which they were formed remain in their interior almost unspoiled. Astronomers also study these objects in an effort to answer fundamental questions. Indeed, is it possible that water and complex organics were brought to Earth by asteroids and comets bombarding our planet when it was still young?
Satellite.
In an effort to answer these questions, the European Space Agency has been developing a unique space mission to study the chemical compounds and physical features of a comet. The mission was called Rosetta and was launched in its destination was the comet Churyumov-Gerasimenko, orbiting the Sun every 6.5 years.
À tous de vidéo, attention pour le décompte final. 10, 7, 6, 5, 4, 3, 2, 1, top. Allumage EAP, décollage.
Satellite ফাটাই দিছি আমি
Rosetta consists of the orbital probe itself and its robotic lander module, Philae. Rosetta is the size of a sports utility vehicle, but when it spreads its solar panels, its wingspan stretches to almost 30 meters. After having already adjusted its course towards the comet in 2011, Rosetta was put into hibernation to save energy. 3 years later, the probe awakened after it had reached the